So our next topic is bitwise operators. Let me copy these. Okay. So bitwise operator means they will do mostly they will do mostly what arithmetic operators did, but at a bit level. Okay, I will show you how. Um, 1 moment. I think I'm in a mistake. Okay. All right. So if we look at we already have studied number conversion, right? Number conversion means so if you have 0, 1, 2, 3, 4, 5, 6, 7. Okay. So this in the byte form is represented as 1, 2, 3, 4, 1, 2, 3, 4 because 8 bits is 1 byte, right? So 1 is represented as 1, 0. Okay, 0, 0, 0, 1. And likewise, this is represented as this is 1, 0, 0, 0, 0, 0, 0, 0. This is 0, sorry, 1, 1, 0, 0. This is 1, double 0, 0, 0, double 1, 0, 1. This is 1, 1, 1, 0. This is 0, triple 1. And rest is 0, 0 only. Okay, so this is this we already have understood and we already know. Now the operations, whatever the bitwise operators do, they do on these bits. Okay, at bit level. So each one is a bit, right? This is a bit, 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 bit. So that way. So next is x and y. Okay. Anyway, we needed the truth table, but anyway, I will show you. So if I say 2 and 5, what is the answer? 0. Why is 2 and 5 0? Because 2 is represented as 0, 1, 0. Okay, and 5 is represented as 1, 0, 1. Okay, now we know from the and truth table, if you compare this 0 with 1, 0 and 1, true and false is what? False only. So it is 0. 0 and 1 is 0. Okay, again 1 and 0 is 0. Again 0 and 1 is 0. That's why you get 0 here in the end. Is this understood?
Yes,
Uh,
yes.
okay. Next thing
Yes.
is you have um, likewise you have R. Okay. Two pipe symbol is used for R, um, bitwise R. 2 and 5, if you notice, you will get 7. That is because again, if you take the same thing and calculate, do the math, 0 and 1 is 1. 0 or 1, sorry, not and. 0 or 1 is 1. 1 or 0 is 1. 0 or 1 is 1. Okay, so I'm comparing this 0 with 1, this 1 with 0, and 0 with 1. And triple 1 is nothing but you saw, so that is 7. Okay, so that's how you get 7 there. Okay, that's about it. And then bitwise not. Bitwise not means if you have 0, it will make it as 1. If you have 1, it will convert it to 0. For example, bitwise of 5 is minus 6. How is it that you're getting minus 6 there? It's because if you have 1, 0 1 as 5. It's converting this 1 to 0, this as 1, but this as 0. Pay attention here. So if you had 5, when you negated it, you got 2. Ideally, you should have gotten 2, but it is actually under the hood, it's not negating only these. It is actually negating the complete 1 byte. So that's why you get 1 1 1 1 space 1 1 plus 0, and then you have 0 comma 1 comma 1. And if you take some online help, binary to decimal, because conversion for us will be difficult. Okay, so if you take, what was that value, take this value, if you take ideally you have to convert to enter binary number. Okay, if you convert, see what you get in decimal form. In decimal form you get it as minus 6. So the way how you get minus 6 is also calculated here. Okay, you can, I'll copy paste this in the uh, code here. Okay, the way how it is, how you have gotten is mentioned here. You can just do the math. So 1 into 2 to the power 7, 1 into 2 to the power 6. That way you, after you do the entire math in assembly language. Okay, this is very important point to remember. Again, not required for Python, but you anyway you have to remember, it's a good point. So any number starts with 0 is taken as a positive number in assembly language. Any number that starts with 1, here if you had 1 something like that, it's, if the starting value is 1, starting value, it is taken as negative number. That's how you get minus there. Otherwise, ideally if you add, everything is positive here, so you should have gotten positive, but in assembly language there, anything that starts with 1 is negative, so that's why you get negative number. Okay, you can do the math here, you will understand how they have done the conversion. Okay, so if you negate 5 you will get minus 6. Is this understood?
Yes, Sabir.
Okay, all right. So the next thing we have is shifting operators. Sorry, we have XOR. Now XOR is interesting. Okay, 2 XOR 3. Okay, so that will give you 1. XOR is interesting. We talked about AND table, OR table, NOT table. Now XOR table is little different. For XOR table, what happens is if you have true comma true, it will make it false. If you have true comma false, it will make it true. If you have true comma false, again false comma true, it will make it true. It will, if you have false comma false, it will make it false. So you see, if you have same values, it will be false. Okay, if it is different value, it is true. This is true and this is taken as false for same values. So that's how XOR works. So now what is happening here is 2 is 0 1 1, 3 is okay, 2 is 0 1 0, this is 0 1 1. If you have same values, it is taken as false, so it is 0. Same values, again 1 comma 1 is same value, hence it is taken as false. Again 0 comma 1 is different value, it's taken as 1. So that's how you have 0 0 1 is 1 only. Okay, that is the explanation for this. 2 XOR 3 means you'll get 1. Is this also understood? Same values means um, 0. I'll write it here. Okay, maybe I'll write here. Same bit values is taken as 0, comma, different bit values taken as 1. Okay, so that is the difference. Okay, the next operator is shift operator. This is
Is
very
this pulling out the remainder like 2 divided by 3?
no, no, no,
XOR?
no,
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 right?
no, no. See, XOR means if you have true values, two true values, XOR will give you false. That's the logical gate. Okay, that's how it has been designed. Okay, if you want to know even in depth, XOR gate is a combination. Okay, combination of two different gates. Hmm. So you have to understand this how they have designed the XOR gate. Okay, so XOR gate has been designed. They have taken the OR gate. For that, they have made certain changes. Okay, one moment. For XOR gate, they have made certain changes to get these values. Wherever the values are same, you will get 0. Wherever values are different, you will get 1. That's just how the design is at chip level, at semiconductor level. Okay, so don't break your head how it is doing, what it is doing, how it is coming, how these values are coming. Don't worry much about that. um, uh, okay, so just understand that all these changes are at semiconductor level. Anyway, so here when you convert this to bits values, and if you compare 0 comma 0, because they are same, you will get 0. Okay, because 1 comma 1 is same, again you will get 0. Again 0 comma 1 is different, hence you will get 1. So that's how, and this value is nothing but 1. So that's why you have the result as 1. Okay, that is your XOR. Now shifting operator. Right shift is, let's just say you want to right shift 5 by 2 places. That's what it means. How do you read this? Right shift 5 by 2 places. What it means is, okay, this is again you have to pay attention to understand. Let's just say you had 101. 101 is 5. Okay, 101 is 5. Now right shift means, see, you have three different places here. Three different places you have. What is happening is, this one is being moved to the right side. Now because there is no right side to move, right side doesn't exist, it is being deleted. Okay, hence 1 is gone. 0 is being moved to unit place, hence you'll get 0 here. 1 is being moved to this place, okay, unit place, hence you'll get 1 here. Now there is nothing to fill here, there is no number here to move. If there is no number, they simply a 0 is added. Okay, is this understood? This is the first right shift. Is this understood?
Yes, Sadik, yes.
Okay, now again 0 is being moved to the right side because there is nothing to move there, it is deleted. This 1 is being moved to this place, hence you get 1 here. This 0 is being moved here, and because there is nothing, a 0 is added. So that's how you get 1. Okay, so if you right shift 5 to 2 places, you get 1. Okay, likewise you can see another example. This time I'll left to shift. Let's just say I have 7. For left to shifting by 3 places, just for the sake of explanation. So you're getting 56. Okay, now 7 is nothing but, if you notice, it's this big number. Okay,
0, 0, 1, 1.
0 triple 1, let's just say 0 1 1 1. Okay, left shift you are doing 3 times, you're moving this here, this here, this here, and this here. So in the next run you'll get 1 1 1 0. Okay, if there is nothing here to move, 0 is added. Again you are moving this to here, this to here, and something else you are bringing to this place. If there is nothing, basically 0 is being added. That's what it means. This will be deleted. Here 1 is deleted, so this one will come here. 1 1 0 0. Okay, now again your left shifting. Okay, this is being deleted. This one you are getting 1 here, 0 0 0. Now this is not happening at only four numbers. It is happening at 8 numbers. Okay, now let me make that change. So if I had, okay, if I had 0 0 0 0 here also 0 0 0 0, 1 byte, right? So all these operations are happening at 1 byte level. For ease of explanation, I took only 3 digits. Okay, now in this case this is not deleted, not deleted, not deleted, only left shifted. So in the first run, so this become 1110. This is correct. Okay, now in the next run this one came here. Now it became 11100. Now in the third run, so this also moved here and this moved here, this moved here. Okay, now this is 110000. That's what is the final answer. Okay, after moving, no, hold on. So how many times did we move? 1 2 3 times. We moved only 2 times, so third time also we have to move. So we'll get 0 1 1 1 0 0 0 0. Okay, now use this same number in the conversion gate. You'll get 0, what was that value? 111 4 zeros, 111. Okay, if you convert, or maybe I shifted twice. Let's see, 1 second. Maybe I shifted twice. Yeah, so I did four times movement. That's why it's showing like that, because initially also I moved one. That's how you got here, right? This is the first movement, second movement, third movement. So I moved it 4 times. That's why. Anyway, so for the third time you'll get answer as 56. But did you understand the shifting operator? Left to shift means you're just moving the numbers to the left at bit level. That's how if you move 7 to left side 3 times, you'll get 56. Is this clear?
Yes, Sadif, clear.
Okay. Okay, all right. So if you want, you can even, I'll just copy paste it here just so that you could understand the conversion, why it is 56. Okay, all right. So that's about it. I mean, these are bitwise assignment operators, bitwise operators. Now we'll see assignment operators. Okay, now we'll see assignment operators. Um, Now assignment operators, they are primarily used for assignment only. If you notice, I will take this. Okay. So assignment operators are used to assign certain value. For example, if you want, you have a variable, okay, called var, and if you want to assign some certain value called statistics, okay, and this operator is just reserving a memory. It will count the length of it, type of it, and basis on that it will assign whatever the memory is required to be assigned to var. So very simple. So I mean, there is nothing for assignment operator equals to, there is nothing I can show you other than this. So it's just assignment, proper assignment. Okay, now another type of assignment is you want to assign as well as increment. Let's just say if I say a plus r equals to 2 and I'll print a, what this essentially means is we are saying a is equal to a plus 2. Okay, a is equal to a plus 2. It means this is what it means. Now if you print, you will get 7, maybe because initial value we had assigned. Okay, let me take it as c, maybe then you will understand. C is not defined. Okay, let me define this c. C initial value was 2. Okay, initial c value was 2. Now I want to do this increment over c. If I print now, it should have 4. So what this plus r equals to means is c equals to c plus 2. Okay. First you are doing addition and then assignment. That's what it means. First you have to add this and then you assign the final value to this. That's what it means. So likewise you have c minus r equal to 2. What this essentially means is c is equal to c minus 2. If you notice the result, you should get 2 value. I mean, they are pretty much straightforward. There is nothing, you don't have to worry much. They are just the shorthand notations of writing the statements. Instead of lengthier, you are writing in a short form. C into 2. Okay, that is what it means. If you print C value, again you will get 4. It was 2, now it became 4. Likewise, you have division also. C divided or equal to 2. What it means is C is equal to C divided by 2. And if you print the value of C, it is 2.0. Okay. So this is done. And mod value. This is remainder. It is trying to get the remainder and assigning the remainder. So let's just say I already have 2 value, but I'm trying to divide it with dividing it with 3. Okay. C is equal to C mod 3. When I try to divide C value 2 with 3, what will I get? Anybody?
1.
If I divide, no, if I divide 3 with 2, I'll get 1. This I will get as 1. Okay. But what will this give me? What will be the remainder? Here it will be 0. Quotient will be 0. Remainder will be 2 only. You see, 2.0. I'm trying to divide 2 with 3. Quotient is 0. 0 times it gets divided. So you'll get 2 only. So you'll get 2. Okay. And now you have floor division. Floor division we already saw. Okay. Floor division means you will get only the upper value. Okay. Only the point, decimal point. Anything that before decimal point you will get. Till unit place we call it, right? So you'll get unit place and above. Okay, let's just say I want to divide 12 is 13 divided by 5, and then I want to divide 13 divided by 5 again, floor division. So this is the difference. If you divide 13 by 5, you'll get 2.6, but floor, because you are going to ignore anything after decimal point, so you'll get 2. Now what happens if you try to do the floor division? Same behavior only, there is nothing new here. Let's just say I want to do a floor division and then print the C value, invalid, non-printable. Okay, why is it non-printable? Okay, let me try with number. So what if, no, this is it not one? Okay, I think I understood why. Okay, so C slash slash equals to 5. It won't, the thing is, for floor division, see, this anyway is floor division, this is understood, but slash also has some meaning in Python. Okay, that's why it was giving unprintable. But anyway, back to where we were. So when you try to do divide 2 by 5 times, where is it? When you try to divide 5, sorry, when you try to divide 2 from 5, what happens? 5 zeros are 0 you'll get. So here we are dividing, right? Okay, leave this, forget this. Pay attention. 5 zeros are 0, remaining 2. This is your mod value. Okay. And this is your floor division, quotient value. So that's why you get 0 there. Okay, floor division always takes quotient. Likewise, you also have equal power. You're doing a power calculation and also assigning. Okay, so you need to have certain value here. So if you notice, this is A is equal to A. Okay, let's just say 2, 4, 4, 5. Yeah, because it has to be C. But it is 0 simply because 0 to the power of anything is 0 only. Okay, let me change the value. I will change the value, and then let's just say C is equal to 2 for simplicity. Now you should get, now if you, okay, I modified the value twice. Okay, now if you see, C value is 32. Okay, this means you're just C is equal to C power 5. That's what it means. Okay, all right. So this is fine. Okay, up until this point it was very easy. Okay, we already knew arithmetic operators, hence combining those with assignment operators was just fine. But now little bit attention you have to pay is that the bitwise operator, that also we have seen already, but we are also assigning together. So let's just say you had 2 and 5. This we already saw. You get 0. If I add 3, you'll get 1. This we already saw in the bitwise calculation. But now what you're doing is you're just assigning. Okay, you're just adding C to certain number, and C here is 32. Notice 32. I will modify that for simplicity. Otherwise, okay, I'll print C. So, I didn't add. Just some problem. C is equal to 2. Interesting. Invalid decimal. It's taking this as. Okay, let me take some other value. Then. Horrible. Okay. All right. One moment. Okay. Sometimes it plays up. Okay. So anyway, d, if I assign d value as 2 and I want to do a calculation of d ampersand equals to 5. Okay, and I want to print the value of d, you'll get 0. Why? Simply because 2 and 5 is 0. That's why you're getting 0. It's just that we are doing the same thing. We are doing the calculation, but we are also assigning. Okay, so this means d and 5, which is being assigned to d is equal to. Okay, that's what is happening here. Likewise, pipe also the same thing. Pipe we already saw. If you give 2 pipe 5, you'll get 7. We already saw this, how the bits are being calculated. Somewhere above here, if you notice 2 and 5. So this same thing is happening. Sorry, 2 or pipe, same thing is happening here also. Okay, but now I'm doing an assignment. How I'm doing is I'm saying d pipe are equal to 5, and if I print d, okay, here it was 0, the value changed, right? So that's why you're getting 5. But anyway, either way the functionality is the same. Likewise, we already have this shift operators and negate operator. So if you have d and or equal to 3, okay, there is some problem. Sometimes it, let's just say e is equal to 4, uh, e cap r equal to 4, and then I wanna, sorry, e, not t, e, and then I wanna print e, so I'll get 0. Okay, so when you negate some positive value, this we already saw, when you negate any true value, you will get false value, which is your 0. If you negate 0, you should get true value. Okay, so that's what it will print. Anyway, so this is done. Right shift we will see, left shift we will see. F, right shift, not F, let's just say E only. Right shift by 2 places, and if you print E, you should again get 0 only, because if you right shift 0, you will get 0 only. But I will modify something here. E is equal to 4 I will assign. Now I will right shift, I will get 1. Okay, now likewise if I left shift by 2 places, and now I print the value of E, I should get 4 back. Okay, so basically you are just shifting the numbers. Okay, so that's what. So if you had 100, which is your 4, you move 2 places, this will be lost, it will become 1. You put it back, you move it back, you will get zeros, hence it will become 4 back again. So that's what it is. Okay, this completes the operators. Any doubts do you have so far that we discussed? Very elaborative topic. One single topic is huge. Any doubts before we move on to another topic?
No, Sadhya.
Okay, so Swapnil, Satya, all good?
Uh, yes, Sadiq. Last one I didn't get it. 256, 256.
256. Okay, so let's just say you have 100 here.
Hmm.
100 you had. 100 means 4. You're shifting 2 places. So this 1 will go to this place, 0 will go to this place. This number will be deleted. This is what the number will be in the first shift. In the second shift, again this number will move here, this will move here, this will move here. So this will become 0, 0, 1. That's how you got 1 here. Okay, if you shift 4 to 2 places to the right, you will get 1, and again you move it back, you will get 4 only. So again you take 0, 0, 1, move it to the 2 places, this 1 will come here, again this move it here, you will get 1, 0, 0. So this is 4. So that's how you have, if you left shift and right shift is giving you the same value for that particular value 4. Is this clear?
Yes, Sadiq. Yes. Thank you.
Okay, okay, all right, no worries. So this concludes our operations, Python operations. Okay, operators. Okay, and there is a little bit here I want to talk about precedence. Now you can ask in what order are these operators are calculated. First operator is operator precedence in the level is, first these brackets are executed, then exponent is executed, then you have plus or minus, sorry, plus x. Basically these are unary operator. Unary operator means you just add plus or minus, you negate the number basically, that's what. So these operators will be calculated. Then you have multiplication, division, addition, subtraction. After doing all of these operations, only then your bitwise shift will be calculated. See, bitwise comes after your arithmetic and other operations. Then comes comparison, and last in the final order, you have logical operators. Okay, this is the order in which it is calculated. Okay, there is no way to. The only option is for you to remember it. If you can't remember it, you can always search for it and know the order while doing the building your applications. Okay, associativity means the order in which expressions are evaluated. There is nothing usually to it. See, certain programming languages, when you type, what they're trying to tell is, when you type 2 into 3 into 4 plus 3 minus 6 divided by 2, then again you take a flow division by 3. So this way you when you combine a lot of operations, certain languages calculate from left to right and certain languages calculate from right to left. Okay, that process is called as associativity. Okay, calculation of operations in an expression from left, in whatever order, left to right or right to left, that is called associativity. And almost all operators have, most of the programming languages do it from left to right. Okay, um, certain operations are done right to left also. Okay, usually it is left to right. If you notice, left to right with operator precedence. And certain operations like exponent, this is done right to left. Okay, only exponent is done right to left, you remember that much, that is more than enough. Don't worry about these explanations. Just exponent is done right to left, everything else is left to right. Okay, in Python. Again, other languages like Haskell, C again follows the same process, but other languages might do it differently. So that's what I'm saying. Okay, non-associative operators means these operators are calculated. There is no exact order for this. Okay, they don't have any associativity related. They can be calculated either from left to right or right to left. You will get the same result basically. That's what they mean. Non-associative operators are nothing but your less than, greater than. Either you compare it with 2 less than 3 less than 4. Either you say, you go from left and say, okay boss, 2 is less than 3, 3 is less than 4. Either you say like that, or you come from right to left. When you come right to left, it becomes greater. You can say 4 is greater than 3, which is greater than 2. Both are same only, right? So that's why less than or equal, less than as well as equal to operators, they don't have any associativity. Either they can be calculated from left to right or right to left. That's what this slide is about. And Python operator overloading. Okay, operator overloading itself is a very kind of how would I put it, a topic where one thing is used multiple times. Okay, for example, if I'm to give you, let me calculate this. For example, this plus symbol, if you add two numbers, no, it will add you the it will give you the sum. But if you add two strings, okay, it will give you the concatenation. Okay, but if you add two lists, again lists can be added only if elements are same. Okay, that also is there. Okay, so if you add so you will get this thing, all the numbers are added. So one single operator is being used. Here it is adding numbers and giving you the sum. Here it is joining. Okay, here it is combining the list. So one operator is being used in different ways. Okay, that process is called as operator overloading. Okay, so just remember what is operator overloading. That's enough for you. There is nothing more to it. We already have seen this. Okay, that concludes our operators. So any doubts up until this point, you can ask me. I'll be happy to answer. If not, we can.
No, no. We get it.